Hi guys, I am Krishant. Today I am welcoming you on a brand new video on our channel. In this video we are going to see about the chapter Gravitation in class 9. So if you have not hidden the like button and subscribe to our channel, do it so that you can see all our videos in the future. So let's get started. Now let us see what is gravitation. It is an attractive force that exists between any two objects in the universe. For an example, let us take two trees. Did you think that any force is in between them? Although we cannot see it, there is a slight bit of gravitational force in between them. Gravitation force is so simple. It's just an attractive force between any two objects. That's it. So this chapter will be so simple. Now let us see what does universal law of gravitation means. Isaac Newton discovered the universal law of gravitation. It states that the gravitational force is directly proportional to mass of the two objects and inversely proportional to their distance square. If we put in that formula, so that it will come force of gravitation is equal to G m1 with m2, which determines the mass of two objects by d square, which is distance square. The value of G is constant and which is 6.674 into 10 to the power minus 11. You might ask, why are we not attracted to each other even though there are force between us? Here is the answer for it. Let us take the same trees, let us keep its mass as 10 kg and the distance between them as 1 meter. So if we put for the force formula, which is G mm by r square, here G, the value of G I have given, and mass, both masses, m1 is 10 kg and m2 was also 10 kg, divided by 1 square because it is 1 meter. So it will come as 6.674 into 10 to the power minus 9 Newton, which is so less, even the friction between us can separate it. So only we are not attracted to each other. Now let us see about acceleration due to gravity. We know that force of gravitation is equal to G mm by r square. Here one mass is mass of the earth, and why we are keeping r is the gravity arises from the center to the crust of the earth. So we are keeping r as the distance between them. We also know that all forces equal to mass into acceleration. So here both forces also same, so we can keep mass and acceleration is equal to G m of earth into by r square. If we cancel this both m, it will come G is equal to G m by r square. What we have seen in before slide is the value of G in the earth crust. But now we will see when the object goes higher from the earth crust and lower from the earth crust. Now first we can see what is the gravitational force when the body moves higher from the earth crust. G dash is the gravitational force when a body moves higher from the earth crust, which is equal to the acceleration in the earth crust into r square by h plus r the whole square. H is the height, how much height you are going. Suppose the object is here and it is 1 meter from the earth crust, so we can keep h as 1. Now we can see how to calculate when it is going deep into the earth crust. G dash is the gravitational force, which is equal to G into r minus h. How many deep we are going, that is the h by r square. Then we need to calculate h from the earth crust, not from the center. Motion of the satellite. Now we can see about the motion of the satellite, and it will revolve around the sun. The word motion of the satellite means that no other energy is acting on it except gravitational force. Only gravitational force is acting on it, which provides centripetal acceleration, which we learnt in our last video. So let's get into formulas related to motion of the satellite. Orbital velocity is equal to root gm by r. We know the value of g, m is the mass of the earth, not the satellite, divided by r. and time period is equal to 2 pi r power 3 by 2 divided by root gm, or we can say this gm 2 pi all are constant, so t square is directly proportional to r cube. Derivation of the v orbital is equal to root gm by r square. We know f is equal to gmm by r square. In this satellite case, the only force acting on it is gravitational force. So gravitational force is mass into acceleration. We know that acceleration is v square by r. If you have not seen our last video, you will not know this. So if we cut this m and then it will come gm by r is equal to v square, or root gm by r is equal to v. Derivation of t is equal to 2 pi r 3 by 2 by root gm. We know that time is equal to distance by velocity. Distance is 2 pi r because the circumference of the circle in which the satellite is moving is 2 pi r divided by velocity. We found the velocity as root gm by r. If we substitute that, when the r goes up, it will come r power 3 by 2 gm. Thank you for seeing this video. Hope you enjoy this video. Please like and subscribe and leave a comment in which I should improve this. So thank you.